Okay, we are working on 5.3a. A shout out to my G Block class. We are recording here live at Millbury High School. And today we're talking about solving systems of equations by elimination. Now you want to make sure you write the date right here, okay? So whatever the date is, you want to write that here. For us, at this time of writing, the date is the February 6th. So far we've been solving system of equations by graphing and by substitution. You know, you graph the two lines and you find out where they intersect, right? Which is this one. You find out where these two lines intersect and that's the answer, right? That's a graphing system of equation. There's the solution. And we've also been using substitution. Hopefully we were just doing that and so you're feeling pretty comfortable with it. You know, you plug in, you put the parentheses. There's a lot of places to make sign errors. It's all good. Today we're going to continue solving system of equations. All these methods work to solve these systems of equations. They can all get the same answer, but sometimes it's smarter to use the elimination method. And I think you're going to like this one. This is the one that people like the most usually, because I think it's partly the easiest. So look at the goal, okay? Read the goal. The goal is to add the two equations together while canceling out. So these are the important words if you want to circle or underline them, while canceling out the x's or the y's. Canceling out is kind of like eliminating, you know? You know that movie, The Terminator? Terminator 2 came out in 1991 with Arnold Schwarzenegger. His job was to terminate people. He'd wipe them out. Our job is to eliminate, similar to terminate, the x's or the y's. You got it? So it's kind of cool. It's like we're in an action movie here. So once we eliminate them, we have just one variable, and we like having one variable. We don't want to have two variables. Check it out, okay? I'm going to color code. I'm going to put a line here, and I'm simply going to add this together, and then I'm going to add this together, and then I'm going to add this together. Okay? Whoops, sorry about that. Could you say that again? Oh, colors. My apologies for that. I can't provide you with colors right now. 2x and negative 2x, I'm making a movie right now. 2x and negative 2x are 0x, yeah? They eliminated, elimination method, gone, poof, no more x's, RIP x's. Okay, so 1y and 1y. 2y. Okay, so again, rip to the x's, and 5 minus 3 is 2. So do we have an equation down low, down there, that can be solved very easily? Yeah, what do? Divide by 2 and we get y equals 1. So we simply divide by 2 and we get y equals 1. We're halfway done solving, but that's the hardest part. So I'm going to now erase all of those colors that I put up there. I'm going to erase all of those and I'm just going to pick an equation. I don't care which one. I don't care which one you pick, but I'm going to use the top equation. And I'm going to take that equation, I'm going to put it down here, and I'm going to use 1 for y. So I have 2x plus y equals 5. I left a blank there for y because y is in fact 1. So I'm going to put 1 for y. This is the same thing we did in the last section. This is just like substitution. We're substituting in. When I subtract the 1 on both sides, I get 2x is equal to 4, and so x is equal to 2 by division of 2. So our final solution, our answer, A and S for answer, is 2, 1. And that's it. We'll put that in a nice little box. That's the elimination method in a nutshell. That's the easiest type of problem. Sometimes they don't cancel out so nice, and part of our job will be making them cancel out nice. But in this case, when we had a 2x and a negative 2x, the same number but different signs, and the same variable, they cancel out good. And the elimination method is your smartest choice for these kinds of problems. So let's keep going down. These are our steps to solving, okay? So if we look through and we talk about our steps to solving, we want to, I think the first step is going to be simply to add the equations together. Add the equations together. Now I'm going to put a little star here. The star means that you can only add them together if they have two variables with the same number, right, and different signs. And if that doesn't happen, that's what we're going to talk about in part 2. You know, tomorrow's lesson, let's say. We're going to talk about how to get there. But for now, we'll just deal with the red ones, if that makes sense. So that's kind of where we're at. So VARS stands for variables. The question came, what does VARS stand for? It's variables. So add the equations together. Step 2 is you're going to solve the new, I like to say resulting equation from step 1, right? Once you do step 1, you're going to have another equation. So I say solve the new resulting equation from step 1. And then the third step is substitute back in to find the other variable. This is something you've already been doing, so I'm going to put a check mark here because we kind of already been doing that. Substitute back in to either equation, really. So you can write that if you want, to find, whoops, I know I got a mix of capitals and lowercase here, to find the other variable. We need a number for x and a number for y, right? So that's the idea. We want to find both x and y. X equals a number, y equals a number, and then we're done. So this is a simple type by elimination, so just look at this example and see if we can figure this out. So add the equations together. That's step 1. It's in black. If we added these equations together, what would we have here if we added them together? Well, the y's are gone, yeah? So we got 8, we got 2x equals 10. Now step 2 was in, I think, blue, and it said solve this equation. So when I say solve the equation, right, I'm talking about this equation. So I want to divide by 2, and I get x equals 5. Now that's the end of step 2, and we're on to step 3, and you can kind of see that, in a way, these are pretty simple. Step 3 says take either equation. I'll take this equation, and I'll say y minus 3x equals 7. But I don't want to put x in there. I want to put in what x is equal to. What is x equal to? 5. So I'll put 5 there. So I got y minus 15 equals 7. And if I add 15 to both sides, I get y equals 22. And my answer would be 5, 22. It'd be written like that. All right? And that's pretty much the basics of solving a system by elimination. So hopefully you're feeling pretty comfortable with the fundamentals of it. So I think as you turn the page, we have a couple of fill in the blanks, okay? So fill in the blanks. Let's kind of go there. Pause the video if you're having trouble keeping up. So we're going to go here, and these are our steps to solving. Step 1 is to add the equations together. Add the equations together. We're on the next page. Add the equations together. Sorry about that. My fantastic G-block class let me know that I was in the wrong spot. We had already talked about that. So I guess where I really want you to be is here. The point of the elimination method, the whole idea is to cancel out. If you think about it, I mean, it's elimination and it's cancel out, right? Elimination and cancel out is kind of the same thing. So the point of the elimination is to cancel out either the x's or the y's. Then we're left with an equation with only one variable. That's our whole idea. We want to get an equation with only one variable. We can do this by adding the equations together. Now, not every time is it going to be beautiful and they add together and it's all gone and it's good. But for today, as we're starting out, that's basically the way it's going to work. So we can do this by adding the equations together. When we add the equations together, what's important is that we need to have coefficients that are the same value, the same number, but different signs. In other words, you need to have equations where you have let's say negative 5x, right, on one of equations and 5x on the other. And then I don't care what we have here. We have 3y equals 1 minus 8y equals 11. Doesn't matter. But that's the important thing, is that these have the same value, different signs. So we want to have equations that have the same number but different signs. Okay. Remember, the goal is to first eliminate one of the variables. The elimination method, lo and behold, your goal is to eliminate one of the variables. Eliminate one of the variables. So that's the last blank we need to fill in. So the next example is pretty straightforward. There's something weird about it, but I think you could try it. I think you should be comfortable trying it. So go ahead and put a line and add those equations together, just vertically add those equations. So let me show you the one I'm talking about. I'm talking about, I think, this example. Let me see if I can find it. This guy, yeah? So I want you to try this example. I already put in what you kind of need to do. You need to add the equations together. And you're going to get a 0 on the left side. Don't freak out. I think you got 0 equals something, right? 0 equals. You can still solve that equation. Just try to get y alone. I think you have 0 equals 4y minus 8. But you can just add 8 to both sides. Divide by 2. And if I'm not mistaken, the answer is 2. Right? Y equals 2. Very important. The question came, was it x equals 4y minus 8? It's actually not, because this right here is not x. This right here is 0, because it's gone. Okay? This is important. A lot of people would put x here instead of 0. They put x like everything's gone. They put x, there's no number. But you don't want to do that. Okay? So pause the video and try this problem. This is your now you try. And I will see you in the next video. Peace.